these are all, the transformations, what's happening. This is the rule. We're going to take this function up at the top, x cubed, and we're just going to write it 4 different times. One that shifted up, one that shifted down, one that shifted right, and one that shifted left. So to go up, I'm just going to write y equals. Y equals means the same as f of x equals, right? So to go up, I could just do x cubed. Give me your favorite number, Parker. Plus 2. So I'm going to shift up 2 on that graph. So the whole graph gets picked up and shifts up 2. How do I shift it down? I just write a minus 2 instead. So y equals x cubed minus 2. All right, Lily, what's your favorite number? Is that a favorite number? 21. So this time we're going to write it inside the parentheses, and to go right, we write a minus sign. And then the cube goes outside. So x minus 21 cubed would shift it right 21 units. And if I want to go left, I just change it to a plus 21. So y equals x plus 21 cubed. So see how this is kind of like inside the function itself? This whole thing is getting cubed. These two are outside the function. You cube it, then you add 2, or then you subtract 2. And the same thing is true with absolute value over here, inside or outside the function. So to shift up, Shelby, give me your favorite number back there. All right, so I'm going to take the absolute value of x and shift it up 13 units. Anyone into like Halloween season? 13 is like a Halloween-y number, isn't it? Isn't there a new Hocus Pocus movie coming out? Is it the same actors from like years ago? Huh. I was never a huge fan, but might have to see the new one. Okay, so I could also shift down 13 units. All right, James, give me a favorite number. 14. So this time I'm going to shift it to the right. So I'm going to put the 14 inside that absolute value symbol to go to the right. Or I could say I'm going to go to the left. So inside, remember, it's the opposite of what you think. Left is actually a plus. And we talked about why that is. We talked about how if you're actually picking the function up, right, and you're shifting it to the left, it is over here. This is the point negative 14 comma 0, because when I plug in negative 14 right there, I get 0. So even though in your head a plus doesn't really, how does that go to the left? It's really the x-intercept that has shifted to the left, because negative 14 now makes this 0. So think about you're shifting kind of your x-intercept left or right. Maybe that'll help you remember that it's the opposite. All right, so then these 4 rules, this is up, down, left, and right. These 4 rules are making it steeper or flipping it over or across the axis. So this one is a negative in front of the function. So you could write y equals negative x cubed, and then inside the function, you'd have the negative x cubed, like that. And this one, you're actually going to see something happen. So if I flip this function, here's the original x cubed function, which you may or may not know, but that's my original. If I flip it upside down, right, then this leg is flipped upside down, and this leg is flipped upside down, right? So that would be it. I just flipped it upside down. What happens when I flip it over the y-axis? This black part goes on top of the green part there. This black part goes on top of that green part. So would you be able to tell these two apart? No, because they have a flip this way is the same as a flip this way, because you'd flip it on top of the green. So if you're looking at it, you might not be able to tell which transformation happened. But let's think about the other function. So what about absolute value? This one makes a big difference. If I put the negative in front, or if I put the negative inside. One of them I can see, and one of them I can't see. So the first one, this is the V-shaped graph, right? Absolute value V-shaped graph. If I flip this one upside down, it's going to look like an upside down V. But what happens if I flip it side to side? I'm actually not going to see any change, right? Because this is going on top of itself. So sometimes you'll see it and sometimes you can't see it, the transformation. Then the last one is making the number steeper. Give me your favorite number, Michael. 10. So if I do y equals 10 times x cubed, that's 10 times as steep. Would you like to make 10 times the amount of money that you do now at your job? Yeah. So if you're making $12 an hour, what's 10 times that? $120 an hour? Yes, please. So think about stretching something 10 times as steep. So same thing with this one. You'd have 10 times the absolute value of x. All right, what if I shrunk your income? So what if you only get to make half as much money? That would kind of stink, wouldn't it? You go from $12 an hour to $6 an hour, right? You're making less money. So my graph would be less steep by a half. So like 1/2 goes in front, or 1/4, or 1/3. The thing that can confuse students sometimes, what if I have y equals negative 5x cubed? What would happen to this graph? You have to think of these two pieces as two separate things happening, right? This is your flip over the x-axis. What does the 5 do? Would it make it more steep or less steep? It still makes it more steep. So because it's not a fraction that's less than 1, it's going to stretch the graph. So you have to be careful. See how this rule says c is less than 1? Well, negative 5 is less than 1, but we're really just talking about the absolute value, this 5 right here. The negative is a flip over. So I want you to take a minute and practice that again. And we'll practice it using this back page first of 205. This way you don't have to be responsible for graphing them yourself. All you have to do is take the absolute value equation up top and figure out which graph matches to it. How many graphs are there? There's only 6 graphs. How many equations are there? 4, 8, there's 12. So you're not going to use every letter up here. So what I would do is look at graph number 1, see if you can figure out which the correct transformations are up top. You might want to write for yourself what happened. So like on number 1, before I go looking for my function, I might want to think about, okay, this is flipped upside down, right? So it's a flip over the x-axis, and it's steeper. See how it's twice as steep? It has a slope of 2. So I'm going to say stretch by 2. So now you're going to look up top, which of those equations has a stretch and a flip upside down? Can someone find that one, just so we've done one together? It has to be flipped upside down and it has to be steeper. Which equation do you think does those things? It is E. So you're going to write E for number 1, and then you can cross out E because you know that you're not going to use E again. So see if you can match the equation to the graph. We'll check them, and then we're going to try the front page. So if I think about where this has gone, it went right 1, up 3. So I know that plus 3 has to be in the equation. It's probably this one right here, right? I see a plus 3 outside. Yep, minus 1 would shift me to the right. So that must be I. Did you get that one? So number 2 should be I. Number 3 has not moved anywhere. See how it's still sitting at 0, 0? What's the only problem or change with number 3? It has been shrunk, right? It's up 1 over 3 now. So 1/3 as steep. Which one did you put for number 3? It looks like K. See how the 1/3 is sitting in front of the function? So that'd be K. Number 4 has moved. It has gone left 1, down 3. So I'm looking for a minus 3 on the outside. It looks like I only have 2 choices, G or H. Both of those shift left 1. So how do I know which one it is, G or H? I look at the slope, right? See how that looks less steep, 1/2? So that one should have been G. People who got that far, did you get G? See how I'm using process of elimination to think about which one it could be, so G is gone. All right, number 5, the only change looks like it is shifted to the right. So I look up here. Shifting to the right is either A or B, right? X minus 2, X minus 2. I could check the slope. This looks like it goes up 1 over 1. It only has a slope of 1. So did you put A for number 5 if you made it that far? Good. So I used up A up here. And then let's see, 6. Left 1, down 3 again. But this one looks like it has a slope of up 1 over 1. So let's see. Left 1 and down 3 must have been H for part 6. So did anyone go 6 for 6 if you had enough time? If you went 6 for 6 and you didn't have to look at the transformation rules, that's really good. If you went 6 for 6 but you still have to look up the rules, that's pretty good because you're at least connecting the rules to the right graph. And if you just need a little bit more practice, we still have today and Thursday to try to get these under our belt, the left, rights, up, downs. So let's take one step a little bit further and see if we can do some writing the equation from the graph. I guess they're not having you graph it yet. You're writing the equation yourself, but then you have to talk about what is the domain and range of the function, what are the intercepts, x and y intercepts. This is the page right before it, isn't it? And then describe the transformation. So let's do number 1 together, and then maybe you can try 2, 3, 4 with a partner or by yourself. Let's do describing the transformations first. How would you describe what just happened to that graph? It has moved where? Everybody knows their left and their rights, right? Because I feel like that could be a problem. If you always get your rights and your lefts confused, you're going to get confused on this. But you know that you hold up your left hand, it makes an L, right? And you know that you're right-handed, most of you, or you're left-handed. So, okay. It has gone right 3. I should check that the steepness hasn't changed. See how it's up 1 over 1? So it has not changed. It's not steeper. Okay, so y equals, where do I put this 3 to go to the right? Inside or outside the function? Inside with x. And remember, inside is opposite what you think. So if you, okay, it's going to the right, I want to put x minus 3 inside the function. So your function would be y equals absolute value x minus 3. What's the domain of absolute value? When I open up this window, see how the arrows are pushing my hands out forever? So domain should be all real numbers, but the range is not all real numbers. What's the lowest I can go? Where's my minimum? At 0. See how on the y-axis, I am at 0, and then I'm above. So y has to be greater than or equal to 0. Are there any x or y intercepts? This is an x-intercept at 3, 0. And it looks like I have a y-intercept at 0, 3. So I have 2 intercepts that I could identify. One is at 3, 0, one's at 0, 3. Think you can try those other 3 practice of transformations? Do your unpause. Okay, my equation has gone just down 6. So I should have absolute value of x minus 6 to go down 6. Does that sound right? I can check that the slope is still just 1. My domain would be all real numbers. Y would have to be greater than or equal to negative 6. Let's see, it looks like I can see 3 intercepts. I've got one at negative 6, one at positive 6, and then one at negative 6 on the y-axis. So negative 6, 0, positive 6, 0, and 0, negative 6 are my 3, 1, 2, 3 intercepts. Down 6 would be how I describe my transformation. Did we do that one okay? Thinking about all that vocabulary? Take another minute or two on 3 and 4. And then we'll. All right, so let's see. This has gone left 3, down 2. So I'm going to write left 3, down 2, and it looks steeper, right? So stretch times 2. So that's 3 different pieces I need to include in my equation. Y equals 2 absolute value, that's my stretch. Left 3 would be a plus 3 because it's opposite what you think. So x plus 3 goes inside, and then down 2 would be a minus 2 outside. That's a 3-part answer. You need a stretch, a left, and a down. Domain is always all real numbers. My range would be greater than or equal to -2 this time. That's the minimum. And let's see, I can see 3 intercepts, I guess. One is at -2 and -4. -4, -2. What's my y-intercept? 4, 0, 4. I've got 2 x-intercepts and 1 y-intercept. All right, so let's see, that last one, oh my goodness, it has all 4 transformations on one graph. Right 2, up 4. So right 2, up 4. It's a flip, right, over the x-axis. So that's going to be a negative sign in front. What's the slope of this one? It's not 1. It's 1/2. So it's half as steep and a flip. I could just put -1/2 in front of the function, right? That would do both jobs. So y equals -1/2 absolute value. Let's see, I need to go right by 2. What do I put inside the absolute value to go right? X minus 2. What do I do to go up 4? Plus 4. So -1/2, absolute value x minus 2 plus 4. So I probably won't do a 4-step equation on the quiz. I'll give you like 1 or 2 transformations at a time because that's a lot to write in one equation. My domain would be all real numbers. What's my range this time? It's different than the other 3. This time I have a maximum value and it's below. So this time y is less than or equal to 4. And I can only see 2 intercepts, but I know it has 3 intercepts. Let's see, this is at 6, or sorry, -6. This is at, looks like 3. What's that other x-intercept have to be? Who said that? How'd you figure that out? It's 6 and 2. Okay, so that's distance of 8 is what you did in your head? Oh, wait, so what did you say the intercept would be? Oh, 6 and 2 is here. So you thought it would be at 8? I think it's actually at 10 though, isn't it? Oh yeah, 7. Yeah, but wouldn't it be 8, 1 because it's only slope of a half? So I think it's actually 10, 0. What I thought you meant was if I look at my vertex, I'm at 2 and I go all the way over here to -6. That's a distance of 8, right? 8 units on the x-axis. So if I'm at 2, I have to go a distance of 8 units on the x-axis. So I would be at 10, 0. That would be kind of a bonus. If I didn't graph it, that'd be kind of a bonus. All right, while I'm giving you your game cards for this absolute value game, there's one page that we didn't do on 203, but this would be a good kind of practice of that graph vocab. See if you can answer these 10 questions on the back of 203. Does everybody see where that is? We didn't do that one yet, did we? See if you and a partner can answer that. We didn't do it, right? Blank. Okay. Back to 203. Increasing, what'd you say? -2 to 0. Should have been increasing. Did you get that one right? What about when x is greater than 4? So this section of the graph right here. Decreasing, we should have said, right? The x-intercept. Now, I should have given you the scale on the x-axis. Did you assume that these were counting by 2s as well? Or did you count them by 1s? Because I should have given you a scale. Let's say that this is also counting by 2s because the y-axis is counting by 2s. But if you wrote that it was -1, I see where you're coming from. -2, 0, and 4, 0. But I would count it correct. If you wrote -1, 0, and 2, 0, there was no scale. That's too ambiguous. The y-intercept looks like it's at 0, 2. That one's labeled. When x is -4, what did you say the y value was? I would estimate positive 4. Is that what you said? Or did you not know how to do that problem? All right, what did you say the maximum was? It says assume the graph is continuing forever. So positive infinity, negative infinity. We do okay on those? It looks like it has one local minimum right there, right? Where is there a dip in the graph? So at negative 2, 0, and then at what is this? 2, 4 would be a local max. Do you understand the vocab max, min? Did you try for a domain and range? It's a cubic function. Do you remember the domain and range of a cubic function? All real numbers, because I can move my hands forever, side to side, up and down. And, oh, I already said cubic, right? Did you identify cubic was the parent function? Yes.